All right, so in these problems, the first thing you're going to have to do is balance it. You can't do mole comparisons without balancing these reactions. So I went ahead and balanced this ahead of time. You're going to have a coefficient of 2, 25, 16, and 18 when you're combusting this octane, which, by the way, is just pretty much just gasoline. All right, so we're going to have 20 gallons, which is about 2.0 times 10 to the 1 kilogram. So 2.0 times 10 to the 1 kilograms. I need to get this in grams. So 1 kilogram is 1,000 grams. So what are we talking here? 20 times 1,000 would give me 20,000 grams of octane. Okay, now we got to get this in moles. So what's the molar mass of octane? Well, carbon has a molar mass of 12. So I got 12 times 8, and then I'm going to add 18. So 12 times 8 is 96, plus 18. The molar mass for octane is 114 grams per mole. So 114 grams per 1 mole of octane. So 20,000 divided by 114 is going to give me 175.4 moles. Now, if we're going to go to sig figs here, we're going to go 2. I could say we'll just go like 180 moles. Now that's 180 moles of octane. So now I'm going to look at the mole to mole ratio for carbon dioxide and octane. So for every 2 moles of octane, I'm going to generate 16 moles of CO2. So it's basically a 1 to 8 factor there. So I already have that mole number of octane in here, so I'm just going to multiply that by 16 and divide by 2. And I'm going to get 1,404.508772, but I'm probably just going to go 2 sig figs on that. So let's just go 1,400. What is that? We're going to have moles. We're going to have moles of CO2. So that matches this part here, I believe. Yeah, 1, 2, 3, 4. I'm off by a 0, but I don't see where that would be. Let's see here. 2.0. That's like 20 times 1,000. 20,000 grams. Everything's right there. I think that's a 3. Shouldn't that be a 3? Well, whatever. Let's do the next one. Now that's my moles, but they want to also know what that mass would be. All right. Well, 1 mole of CO2 would be, 1 carbon's 12 and each oxygen's 16. So 16 and 16 is 32 plus 12. You're talking 44 grams of CO2 for every 1 mole of CO2. So 1,400 times 44 gives me 61600 grams of CO2. So I could say 6.2 times 10 to the 4th power grams of CO2. But again, that's a little bit off there for some reason. I'm just not sure why that would be. All right, let's take a look at the next one here. We have What amount in moles and mass of zinc sulfate? All right, so let's balance this thing. I think it's already balanced. One there, one sulfate, one zinc, one zinc. Okay, so everything's a 1 to 1 to 1 to 1 mole. What amount in moles and what mass of zinc sulfate can be produced when 433 grams of copper 2 sulfate? All right, so here's my copper 2 sulfate. That's 433 grams of copper sulfate. So let's get that into moles. All right, so molar mass of copper sulfate, we're talking copper, I believe, is what, 65? No, copper's 64. So we're 64, sulfur's 32, and you got each oxygen is 16, so 4 of those would be 64. So you're talking about, let's see, 160 grams per 1 mole of copper sulfate. So 433 divided by 160 gives me 2.7 moles of copper sulfate. Now, you don't want to stop here because you have to consider, am I going to run out of copper sulfate or zinc? We need to find out which of these two quantities is going to limit me. So 484 grams of zinc. Molar mass is zinc. Zinc is 65. So we could say 65 grams per 1 mole of zinc. So 484 divided by 65, we're talking about 7.4 moles of zinc. Now, I'm using the copper sulfate and the zinc in a 1-to-1 ratio. So if I use 2.7 moles of copper sulfate, then I'm only going to use 2.7 moles of zinc, and we're talking about having 4.7 moles of zinc left over. All right, so I'm going to have plenty of zinc. I'm going to run out of this. So if I use 2.7 moles of copper sulfate, then I should be able to garner exactly that many moles of zinc sulfate. So what amount in moles of zinc sulfate? I should be able to garner that same exact moles. 2.7 moles of zinc sulfate. Now they also want to put the answer in grams. So let's come back and get that back into grams. 1 mole of zinc sulfate has a mass of, zinc is 65, sulfur is 32, and then zinc is, zinc 65. Zinc is 65. Each oxygen at 16 apiece, 16 times 4 would be 64. So we're getting a molar mass of about 161 grams. So 2.7 times 161 should give me a mass of 434.7. If I'm going to go 2 sig figs on that, I might say, okay, that's 430 grams. And I'm really close to this. I think the only issue is I probably should have said, hey, look, the molar mass is actually 65.37. And that's going to make this number right here a little bit greater, and it'll come out to be more like the key here, 438 grams.